Bismillahirrahmanirrahim. Assalamu alaikum. This is the episode 1 of season 4, Introduction to Electronics. Before this, we had already discussed season 1, season 2, season 3. 3 seasons are available on this EasyLearn platform. In season 1, we discussed some basics things about electronics very deeply. For example, we discussed electrons, their valence shell, and their basic fundamentals. While in the season 2, we had moved one step further and we tried to discuss the logic gates and the binary language. In this season 3, we discussed general things about the electronics like resistors, diodes, and their introduction. And in the season 4, we are doing the same pattern, and we are further continuing this same strategy and try to discuss these things precisely. As you know already, if you are watching the previous seasons you watched already, then I think you know what is this series and what this series means. This series is not have a particular target on the specified type of audience, and I'm not also focusing on a specific course. This is a randomly I select topic and I discuss here, which I think this must be necessary for the introduction before going and further discussion. So magnetism, I select this topic, first topic for the season 4 episode 1. So let's start this topic. First of all, let's discuss some history here. The magnets are we know about the details of the magnet from ancient times, and there are two main properties of the magnet which we know from the very early. We have knowledge about these very early. For example, the first property is direction seeking. We are taking the benefit of the magnet, benefit of compass, like direction seeking property. And this is very old. We are using it approximately more than 200 years. We are using this property, and we have the knowledge of this ability to attract iron and steel. This is also very important, and we already know about this thing. While this is an horseshoe magnet, and it is made up of alnico and iron alloy. A third important property was discovered. This is the third important property, and this is very important. This is the property and the reason why I add this topic in my series Introduction to Electronics. This is the main property and relevant to our course, and that is discovered in 1819 by Professor Oersted. He discovered this when he was just preparing and performing an experiment in the lab, and when he turned on an electronic circuit, he noticed that the compass placed nearby to the circuit has changed its direction, and the needle effect when he turned on the circuit, and when he turned off the circuit, the needle again points the right direction towards north. Then he noticed that there must be some relation of the electric current and its because it affects the direction. So that at that time electromagnetism is discovered, and he tried to do some research on this, and later, 1 year later, the Professor Oersted received the prize, and the Royal Society of London awarded Oersted the Copley Medal in 1820. Magnetic effect always accompanies an electric current. This is the main thing which Professor Oersted was credited for the discovery of this thing. Okay, so this is, you can see that the animation of the DC motor. There is a north pole and a south pole, and this is the main main discovery. And after this this is discovered after when permanent magnets are used in the DC motor. And the process, the third important property is when discovered electromagnetism. Then we scientists later on discovered DC motor, and it is very useful because after the discovering, the inventions continued, and scientists made radios to use it in the radios and loudspeakers, microphones. Not motor is used everywhere, but this principle is used, electromagnetism, in the microphones, transformers, meters, and other things. You can discuss these things. We will discuss these things in details in the other series, because this is not the series where we are going to discuss all the things in this short limited time. So very complex computer lasers, and here you can see that this is the DVD player open, and here also the same process is used to write the DVDs and to read the data from them. Lasers and compact discs, video recorders, electric cars, and many other inventions of this are connected to the electromagnetism process. Electromagnet is also used to sort out the material in this scrap yard, and when we turn on the switch, it becomes the magnet. With the process, electromagnetism means artificial magnet with the passage of the electric current, and it is also discovered when electromagnetism is discovered. Magnets are used in the industry and in the home, better. CT scan is also a very good blessing, and before that, only surgery is possible, and now CT scan is very popular, and the nuclear magnetic resonance scanner can help find cancers. We can take the CT scan with the help of this on the screen of the computer. We can see, you can see that we can easily monitor all the data of that is collected through this machine. Basic principle of the magnet, this diagram that you are seeing is called magnetite. This is basically one of the main iron ores, and one of the main iron ore is part of the naturally occurring rock, which the old and initial people, Anglo-Saxons, who discovered that in the early age, named that stone on the type of which they use it for the direction seeking, and they name it in their local language as a lodestone, which means that direction stone, because they use this stone as a direction seeking purpose, means as a compass, not in this form that we are using nowadays in a very modified form, but they are use it in a different way. Like if we place the nails on this, you can see it attracts, and due to the attraction principle, it is very useful, because earth is naturally also magnetized and a natural magnet. So it was used by early navigators as a compass. I will also show you a diagram here, which I'll also describe. When we place a magnet, and you will see that there are the two opposite poles always developed. There is no magnet which do not contain these poles. There is no magnet on the earth available. North seeking pole, okay, and the south seeking pole. Every general magnet which is found in the natural form has a north seeking pole as well as south seeking pole. These are the opposite to each other. North pole or simple south pole, we can also say that. For example, this is a magnet. The first property of the magnet is it attracts the iron and steel. Second property is when we take a bar magnet, this is a bar magnet or any other magnet, one side is north, towards north. This is, you can see one side is north and the other is south. Opposite, north seeking pole and the south seeking pole. When it is free to move on a pivot point, pivot means when we balance it on the center of the gravity and it is free to move in any particular direction, you can see that it always tries to point in the north direction. If I change and by applying force, if I change its direction, for example, this is the direction now, for instance, I change its direction to like this, it will try to go like a compass in the same north seeking pole. So if a magnet is divided into two smaller pieces, each piece act as a magnet, while the north pole and the south pole, it is impossible to produce a single north pole. That is what I was trying to discuss in the previous slide, second last slide, that there is no magnet which is available as a single pole, for example single south pole or a single north pole. This is not possible, because if, for example, let's take an example of this magnet. This is a simple magnet, bar magnet, which has a north pole, and the opposite pole is of course south pole. If I try to divide and cut it from here, it doesn't mean that this half is the north and this will become south totally, but it changes again. The half of it will be act as in north, this side is north seeking pole, while this side becomes south seeking pole. Same is the scenario here. And if we further cut it, then you can see that still it will manage it in such a way that one side is north and the other is south. And this is the basic properties of the magnets. This is called dipole. Di means two, so they are always found in the combination of two. This combination is called a dipole. Imaginary tiny magnets, or the dipoles, lined up in a linked in chains inside these are the magnetic lines of forces. We will discuss what are the magnetic lines of the forces later on in the details, but in general you can say that when there is a north pole and there is a south pole, and the lines of the forces are like this from north towards south, it will always make a pattern of this. It is going too far from the north side, means direction is outside towards the outside from the north pole, and inside towards the south pole, always magnetic lines of the forces. Magnetic line of forces is always found to be in line in a particular pattern. As you can see that all lines are inlined. Rather, this is the ideal scenario. And if, for example, there is a magnet which has poor quality or damaged or anything else, or maybe influenced under another magnet, then the magnetic line of the forces may be changed. But in general, it is always pointing towards south, from south towards north. And this is a simple steel bar. This is the magnetic steel bar, magnetized steel bar. Okay, magnetized steel bar, while this is unmagnetized steel bar. Here you can see that there is no north pole or no south pole, because magnetic line of the forces are not in line. They are randomly pointing in any direction. Okay, this is the end of the discussion, and I want from you at the end a simple basic quiz. If I provide you with a mixture of the powder of aluminium, iron and nickel, and I give you a magnet, for example, or if you have any other options available, which part you can separate and how, you can tell us in comments, and I will upload the answer on our Facebook page. So further discussion will be continued in the next episode. Take care. Allah Hafiz.